It's time to go back and revisit Newton's second law, which is F equals ma, force equals mass times acceleration, and to recall that acceleration is defined as the change in velocity with the change in time. If I substitute delta v over delta t for acceleration, I get mass times delta v over delta t. Cross multiply both sides by our change in time gives us this new equation, which we haven't seen before, but it is, in effect, Newton's second law in another form. The force times the time that force is applied is called impulse, and m delta v is the change in momentum. Momentum is a new concept for us. P is the symbol for momentum, and P is mass times velocity. So Newton actually wrote his equation as F equals the change in momentum with time. This is for those of you in calculus. What you have to understand is that by using the deltas, the changes in, we arrive at the impulse being equal to the change in momentum. This is for constant mass. In reality, in calculus, we have to allow the mass to change as well. But we're going to be dealing with objects, except in rocketry, where the mass doesn't change. So the change in momentum is just the change in velocity times mass. So impulse, force times time, equals mass times the change in velocity. We could also think of the delta t as being associated with mass instead of velocity, and then we would get mass over delta t, which is the change in mass times the velocity. So if we have a rocket, the thrust could be thought of as the exhaust velocity times the speed at which the rocket is consuming fuel. So this is an interesting second version of the impulse equation, and both should be memorized for the SSAT. So we have the main impulse change in momentum equation, this guy. Force times the time the force is applied is the mass times the change in velocity. And in rocket problems only, the thrust is equal, which is a force, the thrust is equal to the velocity of the exhaust gas times the rate at which fuel is being consumed. So again, when we think about doing rocketry problems, we're going to have to understand that a rocket has to overcome gravity before we get any lifting thrust. So we'll bear that in mind when we do problems. But for right now, we've introduced this new version of Newton's second law. And after we do a few problems with it, it'll become obvious why that is so valuable to us. And again, momentum is little p and is equal to mass times velocity. So we're not introducing a new concept. It is still Newton's second law, but expressed in a different form. And in fact, by the time we've finished, we're going to have 3 or 4 ways to look at the same kind of problem using the same physics rearranged in different forms.